We have a saying in French, actually. I don't know if it's the same in English, but we say that best is enemy of good.
Yes. Welcome to the LabVIEW experiment. I am your host, Sam Taggart from SAS Workshops. In my 15 years of working with and training developers, I've had the opportunity to conduct a lot of experiments. Over here, we believe in embracing failure as the essential learning experience that it is. And what better way to learn than from other people's mistakes? In this podcast, I talk to industry experts, colleagues, and friends about their failures and how they have turned them into future successes. I am here today with Cyril Gambini. He is from Neosoft up in Canada. He is a
Yeah.
DQMH Trusted Advisor, LabVIEW champion, all those good things. Um, so I thought we would start today, Cyril, just talking about VeriStand and TestStand, because that is something that I do not use a whole lot. And so maybe you could explain exactly what VeriStand is. I know it has something to do with hardware in the loop testing, but like what is it? What does it do?
Yeah, definitely. Yeah, VeriStand is kind of a shell. If you want to use uh, PXI system, compact Rio system, or real-time system, but it can even run on Windows actually. And you want to run point-to-point actually system in loop. So you can actually acquire data, calculate data, and produce outputs, but it's all point by point. So if you're running on a real-time system, maybe you want your loop, your main loop, actually to run at 1 kilohertz, let's say. So we'll take 1 point on every input you have, every 1 kilohertz, and it will go through models, for example, if you have models to manipulate your input and create maybe values for your output and then push the output. And you repeat that every 1 kilohertz. So it's one point by point system. So we use it most of the time on HIL systems, but we also have a customer actually that use VeriStand for something very different, and it's not linked to anything that is related to real time, but it uses it because VeriStand is actually pretty easy to configure. So if you have a system with multiple input and outputs, and your system actually changes in configuration often, in VeriStand you have what we call a system definition where you can add a target and you can add input, outputs, you can add modules, or we call that a custom device in VeriStand, and you can map your signals and you can deploy that and it will run. So yeah, one of our customers is actually in the energy field and using compact Rios to make measurement, but the interest is not to do it in real time. There is no closed loop nowhere, it's just to gather data. But every system he measures actually is different from the other. So instead of having a super uh, configurable platform, he actually uses VeriStand to build the DAC system he needs at the moment he needs. And
That's
he can deploy that on it's a distributed system for that customer. So he has maybe 10, 15 compact Rios all around a facility, and it deploys VeriStand on each one of them. So each compact Rio is autonomous and pushing data back to the operator. So it's kind of cool stuff. But main goal of VeriStand actually is to be used on Linux RT system or RT system. It works also on ForLabs, but ForLabs is now deprecated. But so it was targeted to run on real-time systems, actually.
So you mentioned HIL. What exactly is HIL? Because I feel like that's a term that lots of people throw around and
Yeah.
nobody
So
really
you
define it.
HIL stands for hardware in the loop, actually. So you have a piece of hardware that you integrate into your closed systems. Let's take an example. We often use VeriStand in aeronautic project. So we may have a LRU, for example. Imagine an ECU for a plane. We can imagine. I imagine it like this. So computer, and you need to stimulate that computer with sensor values, for example, that you actually, yeah, simulate. So you kind of try to recreate the environment of a piece of hardware and see how this piece of hardware actually react to that simulation. So yeah, definitely VeriStand can be used for hardware in the loop systems. We can also use it for system in the loop system, SIL. So it's a little bit different, but here you have a model, for example, of your system. It's not designed yet, but you have a Simulink model that is mimicking the behavior of an actual product that you plan to make, and you want to ensure that your product will react correctly. So you can create a model in Simulink, compile it, and create a .so. So it's a compiled model that you can run on RT target. And so you can have VeriStand just getting that model, send it to your RT target, and you can send data from the real world to that model and see how it behaves actually.
That's cool.
So
Yeah, so it's more of a
yeah, that's kind of,
design tool for designing systems as opposed to testing things in that case.
yeah, in that case, yeah, instead of spending time to build an actual prototype, you just can spend a little bit less time doing a digital twin and actually run it and see how it will behave. And from that twin, you can actually then create a almost final prototype.
I was gonna say a lot of it probably depends on how close the model matches the actual thing you're producing.
Yeah, that's the game. I actually, yeah, that's it's pretty hard, but actually the simulation part is not on our side. Most of the times, our customer do the simulation, and we integrate the simulation into a VeriStand system, and we are closer to actual signals, so we integrate DAC systems for input and outputs, for example. For aeronautic stuff, we also have a bunch of systems that are actually acquiring or pushing ARINC data, so A429 or A664, A825, sorry, protocols out there. And it's all controlled actually by VeriStand. So yeah, at the end we can have kind of very, very cool systems. We sometimes have the biggest one we've made at close to 10,000 channels running at 1 milliseconds. So each channel, imagine one channel is a data point, input or output, and you need to get them or update them every 1 millisecond. So that number of channels coming from different sources, etc., it's kind of impressive, and VeriStand works quite well for that, or at least it allows us to scale quite well.
Yeah, I always find I've done some PLC projects where you have a lot of channels and just managing that many channels gets to be cumbersome.
Yeah, yeah, yeah. So it's in our Aeronautic project, we have most of the time PLCs are still there to control very complex systems. So they are still in the place. So VeriStand is not replacing a PLC. But if you need to actually insert a model into your system, it's pretty hard to do it with a PLC. So that's where VeriStand really has a very good point here, and you can really get models, etc. And also with PLC, you have to compile your code, send the code to the PLC, and see if it works, etc. With VeriStand, it's much more a question of building a system definition. So it's right click, right click there, right click there, and you actually map things out and you just try it.
Yeah.
And so it will deploy in the target and see what happens actually. So it's a little bit smoother than updating a code running on a PLC.
Yeah. Yeah. So like the one application where I did some hardware in the loop stuff, we didn't use VeriStand. We used something called DSpace, which I guess is a
Yeah,
editor. But
yeah.
yeah, I didn't pick that. They already did. But they were testing flow meters and they had flow meters, but the flow meters came in different sizes and they were actually testing the transmitter. So the flow meter generates some signals and there's a transmitter that then converts it to some protocol. And the problem was to test the transmitters, you needed to test it with like all the different sizes of pipe diameters. And so that got to be very cumbersome. And switching out the test rig for one size pipe to another was a big problem. So they would just use this rack space or D space thing to simulate the different pumps,
Yeah.
sorry, the different flow meters for the different diameters. And that worked
But
really well because their testing time went from like, a week down to like an hour or something. Because it
but
was,
yeah, definitely it helps a lot. Actually, DSpace is a concurrent to VeriStand, so there are some others out there, but we find it pretty VeriStand actually pretty powerful for what we need to do.
Mhm.
And the biggest advantage is that you can integrate it with any third-party boards that may fit into a PXI chassis or in a compact radio chassis. So with DSpace, for example, you are very linked to the DSpace ecosystem. And the force of VeriStand is that you just execute, actually it's LabVIEW code that is executed on your target at the end. And so if you can target your device with your LabVIEW code, you can actually target that device in VeriStand. So it allows to really be able to have a wide ecosystem of hardware that you can use. Actually, you are not stuck with National Instruments solution.
Does it also do FPGA stuff too? Can you like hook up like
Yeah,
videos and stuff? Yeah.
yeah, you can actually deploy bit files, so you can create your own personalities that you deploy on FPGA boards and get, for example, you can even create a model onto your FPGA board, deploy it thanks to VeriStand, and you map your input and outputs to external signals or models running out there, etc. So yeah, it's pretty configurable.
So the other thing that I associate with you besides VeriStand is TestStand. So do you use those two together, or are they two separate?
Uh, Actually, it's pretty rare. We did few things to automate VeriStand using TestStand, but it's actually pretty rare. Most of the time, people using VeriStand wants to have a sequencer that is able to modify channel values within the time loop of your system. So VeriStand has a sequencer that is actually executing on the target. So we have a sequencer there. That's
Is that a sequencer you guys wrote, or that just comes with VeriStand?
it's come with VeriStand. Actually, it's an add-on or yeah, it's a tool that comes up with VeriStand. So you can create a sequence that actually runs on the target itself, and you can just start sequences based on threshold, for example, on input and a few things like this. So it's when we use VeriStand, we stay most of the time in VeriStand as much as we can. But sometimes you need VeriStand because you will use the capability of VeriStand to run on real-time target, but you need to automate things that an operator would do manually. And so in that case, you would run a test and sequence. And we have what we call ASAM-XIL steps. So these are test and steps that allow us to send to VeriStand orders and to get feedback from VeriStand from a PC. So we might change values of input channels, for example, from testing and get a result, etc. So we can do actual testing on real-time system. So they mix, but to be honest, we don't mix them often.
Okay. So TestStand, I know you use DQMH and TestStand a lot. What are some of the challenges with that, and how have you overcome some of those?
So yeah, just a quick clarification. I use TestStand a lot.
Mhm.
Do I use the QMH with TestStand a lot? It depends, actually. So there are advantages of using the QMH with testing, but there are also caveats. So it depends of the project I'm working on, and I'm not using the QMH all the time, actually, with testing. But we tend to use it more and more. There is a specific reason for that, is that, yeah, at Neosoft Technologies, we are DQMH Trusted Advisors. And so most of the employees that we have, or not to say all, we all know DQMH very well. But all employees do not know TestStand very well.
Ah,
So the idea was to leverage our knowledge of the QMH into test-stand systems, even for people not knowing quite well test-stand, because test-stand is kind of a beast. It's very powerful, but it requires that you really understand how it works, and it requires also some discipline to use it correctly. And so sometimes it's a ramp up to use TestStand is kind of long, actually. And so the idea was to leverage the knowledge of our employees to use the QMH in TestStand. So the idea was that people would actually create the QMH module, and some of us, or even the same developers, could create simple sequences, just calling public API VIs from the DQMH modules they created, actually. So yeah, it's in that combination, it's very interesting. Uh, but DQMH is not the answer to everything in testing. And there are some pros and cons of using DQMH actually with testing. I made actually a few presentations about this. And so to help actually our employees using the QMH more and more with testing, we created a tool that I presented in iWeek, so a few weeks ago, that we call the Teststandifier.
hmm.
And the Teststandifier actually tries to adapt the QMH module to be efficiently used in testing. So the idea is to look at all the caveats that we actually see using the QMH module in testing and try to remove them one by one. And we do that by scripting because it can take time. It can take time actually doing it manually. And so we decided to create a tool to automate that. And so that's the Teststandifier.
So if people want to know more about that, they can check out your NI Connect presentation.
Yes, when it will be available. And I made few presentation for those who are speaking French. I made some presentation at the Luge, which is a user group for Francophones countries. And otherwise, yeah, people can contact me. But moreover, the Teststandifier is free actually, and it's available on VIPM. So the best is to actually download it and use it, and see how it works. But on average project that we have, where we mix the QMH module with TestStand, this tool made us actually, uh, yeah, it really cut the development times by several orders of magnitude. Adapting a standard DQMH module, let's say you have 10 request and reply, and you want to adapt it the way the Teststandifier does it, it might take 2 or 3 hours to do it. And the Teststandifier does it in less than 2 minutes. So it can really, really help uh, uh, leveraging DQMH with testing. So yeah.
So for DQMH, right, there's lots of frameworks out there. Why did you pick DQMH?
That's actually a great question. Uh, um, if I take a step back, before using DQMH, we had a framework that we made internally. It was based on events that we maintained, etc. So, but we were the only ones actually maintaining it, and it was kind of hard to teach that framework to newcomers in the company. So we decided to actually stop trying to spend time to maintain a framework that only us know, and try to see if we could leverage a framework that was existing out there. And so in LabVIEW, there are many frameworks, but there are two main frameworks that people know. It's Actor Framework and DQMH, actually. So I went through both of them, Actor Framework and DQMH. And the idea was to keep in mind that we had to train new employees quite fast to be sure that we could let them work on project as fast as possible.
Hmm.
And Actor Framework, the ramp up is actually much bigger than with DKMH. And so the idea was to, and it's very object oriented, etc. So you have to know some concepts of OOP. So it was kind of hard. And I don't know for the rest of the world, but here in Canada, finding people who know LabVIEW, it's a challenge actually. We will get people going out of university with basic knowledge of LabVIEW, or people who learn LabVIEW by themselves. And so most of the time they do not have enough experience to understand or leverage all the capabilities you can get from the Actor framework.
Hmm.
But then with the QMH, it was way faster to actually train people to let them understand how it works. And we can even have we have employees who are architects, so we can have architects actually creating the module and have newbies just using the public API in a global project. So it's also pretty easy why people are trained to bring them on a project as a module user instead of module architects
Hmm.
and speed up actually the development and the time required to actually achieve a project or finish a project in time. So DQMH, it was the first reason actually to use DQMH
Yeah,
among others, but yeah.
yeah, that's something I hear a lot is people have trouble finding beginners. And then also, yeah, I've heard Steven say that like, oh, you can just do actor framework projects and you have the architect create everything and you hand it off to a beginner, but I haven't seen that work in practice. So,
Yeah, no, we have several projects made in Active Framework. So project that we did not start, to be honest, and but we now maintain them for some customers. And even if we have quite advanced knowledge in LabVIEW and advanced knowledge in Actor Framework, it's always more difficult, according to me, actually, to change a system made in Actor Framework rather than a system made with DKMH.
yeah.
So with all the systems we have that are made in Actor Framework, it's always a challenge when you want to change the behavior of that software, and we need to really think more.
Yeah.
Actually, we need to work a little bit harder when Actor Framework is used. So yeah.
Yeah, I've had that complaint and I made that complaint to Christian once and basically his response was, well, if they were really well-written actor framework projects, you wouldn't have inherited them. So maybe there's a little bias there in that like, I don't know. I found for me, actor framework projects that I create, where I created the structure and the trees and I kind of know where everything's happening, I find them very easy to change. But when I inherit somebody else's, I find it very hard to change. And I don't know if that's like lack of documentation or the fact that, as Christian said, I'm inheriting them because the person who wrote them can no longer maintain them or no longer able to, or I don't know.
But when you have the big picture of your application, it's okay. You can imagine the tree and
Yeah,
see how it
exactly.
works, etc. But you just, when you inherit from a project, you did not participate to the actual initial architecture, and you just inherit that project, and you have to discover how it works. It's not that easy.
Yeah. Well,
And yeah,
I was gonna say that's one thing I've noticed, like actor framework projects generally don't come with like a documentation. There's like the actor tree. Like one of the first things I have to do is like
yeah.
go through and see which actor launches which and all that. Uh,
It's like people were trying to make it work and they were exhausted at the end and they had no time for documentation or it's very hard for us, or at least it's my experience, but for every project we inherited and that was made with actor frameworks, there is little to no documentation at all. So yeah, uh,
I would say that's true for most projects I inherit, though. But
what we see is that more and more people are using the QMH, and when you know anti-doc, at least you've got it. And if you don't have it, you just can run it. And you have documentation, a basic overview at least of your system in few minutes. So it helps a lot, actually.
yeah, that was going to be my next comment that I like inheriting DQMH projects. I don't know that they're necessarily any better written or whatever, but the anti-doc, just being able to instantly press one button and see which modules are talking to which modules and seeing that layout and that graph is really interesting and really
But
useful.
in terms of quality, you can just mess up as much in DQMH as in Actor Framework. So DQMH, if you don't know what you are doing with your architecture and you just try to put things together and make them work, it will be a bad software in DQMH and in Actor Framework. When you run Antidoc on some project and you see the graphs that it generated, ooh, sometimes it's crazy. It's even crazy that Antidoc can even create a graph.
Yeah.
And so yeah, but at least you've got it. So it doesn't the QMH, according to me, the QMH doesn't create better applications. But if you actually follow all the rules, so you document your modules, you document your requests, etc., and you play the DQMH game, uh, at least you've got the documentation done. At the same time, you are programming. And so that's very, very valuable at the end when you run Antidog because you've got some things that you can understand.
Yeah, yeah, it brings up a point I've been thinking about lately. Like the advanced tools, like I put active framework and decommission that category. Like using advanced tools by themselves just enables you to create more complex messes.
Yeah, definitely,
Yeah.
yes. Yeah,
So like it's not enough to just say, oh, I use active framework, I use decommission. You still have to do all the design work and you still have to think about like where the messages are going and how you divide things up. And I've seen some of those graphs. There was one where somebody posted something on one of the DQMH forums and they showed the anti-doc graph and it was giant. And I
yeah.
traced through and I found like 10 circular dependencies like immediately. And I was like, and then he's like,
Okay.
oh, it doesn't work. It takes forever to load and all these problems. I'm like, yeah, I can see that. So
I mean, to architect an application, you still need an architect, actually. So if you are not an architect or not trying to do architecture work, at the end, you will always have a mess, whatever the framework you are using.
yeah. Well, I will say one thing. The one thing I like about actor framework compared to DQMH is that it has the actor tree and that kind of constrains some of the communication because DQMH, messages going everywhere. But I've inherited several actor framework projects lately where they just share the enqueuers everywhere. And
Okay, so
please,
yeah,
for the
you
love of God,
break.
don't do that. Please. If
No.
you're writing actor framework projects and you're like passing enqueuers around, there's probably a better way.
Yeah. But actually in DQMH more and more, we have our that skeleton that I was talking before, that base applications that we maintained earlier, we rebuilt it with the QMH actually. So we have a base structure where when we begin a project, and we actually created a tree. So we have a main and we have a screen controller and we have a process controller. Screen controller launches modules that are screens and process controller launches modules that are processes that are different from screens. And we try to build up a tree ourselves. So DQMH does not enforce that, but we do in terms of architecture. So sometimes it's more a constraint. We have, for example, to forward messages which is not a concept that is very clear in the QMH. And but actually we do it by design, by default.
Mhm.
But more and more, I was thinking about that, and it's based on discussion we had with some other DQMH trusted advisors. The idea to build a tree was actually to reduce the coupling.
Mhm.
And we can create very coupled DQMH modules with DQMH. And if you try to build a tree, you will actually remove or yeah, try to remove the coupling between your modules. But the idea is to understand, is it good to remove the coupling or not, actually? Do we need to spend some time decoupling things, or do we need to spend the less time possible to have a system working? That's
That
that's
is a
something we can debate, actually.
yeah, no, I think there is something to getting things out the door.
Yeah.
And you know, coupling is one of those things where like you can't have a good program without some level of coupling. So the question is how much coupling is good and bad and where does it get in your way? Um,
So yeah, the idea actually with the framework we have was to minimize by default the coupling between the KMH modules. So we have a tree,
yeah,
but yeah, it will depend on how aggressive the timeline is to finish a project. We are consultants, so we need to be efficient.
yeah,
We do not have an infinite amount of money or time for each project, and so we need to be efficient for each project we work on. And so yeah, sometimes we just couple modules because we know the application will work this way, will never change or should not change until it changes. But yeah, most of the time we try to avoid coupling. But yeah, the idea is to really find out if decoupling module is really necessary.
yeah. Well, I feel like coupling is one of those things, coupling and dependencies are one of those things that like separate average or mediocre programmers from good ones, and that the mediocre ones kind of like stumble through that and don't really think those things through very well. And I feel like I'm all for accessibility and I'm all for like bringing in new people and stuff, but sometimes if you make like DQMH makes creating modules so easy, right, that it lowers the barrier to creating modules. But because the barrier is lower, you don't, the people who start creating modules now haven't thought through the whole dependencies and coupling side of things. I don't know. Just seems like a weird paradigm.
Yeah, but if you make things, it's a paradigm we see actually with LabVIEW in general. When you have tools that make it easy to do things or to get fast results, you tend to not think too much about the overall application and the overall architecture of your system. You just try to speed up and use the tool as it is, and you end up having kind of a mess. But it's a mess because it was easy to create a mess, actually. This is something we see often in LabVIEW. Oh, I can do things quite easily in LabVIEW. It's fast and I can do things fast. Yeah. And 3, 4 weeks after, it doesn't work anymore. It was working before, but it doesn't work anymore. Yeah. You hit the limit, actually. So you've created a mess that works well for maybe weeks or months, and now you are adding something, it doesn't work anymore. And here comes a problem. So with the DKMH, it's also the scripters are fantastic, and it's pretty easy to have a module, a public API, things done well at the module side or on the module side, but on the global application or at the level of module integration, you can really mess up quite fast.
Yeah, definitely with like the circular dependencies and things like that
Yeah.
and other issues. Um, so I want to come back to something we talked about, anti-doc and the graphs. You've worked on that a little bit. Do you want to talk about that?
Yeah, actually, the graph that is describing the modules interaction in an application. So that big graph that you get at the beginning of an entity documentation is actually made with Graph Builder. And Graph Builder is an open source project I made and maintained for three, 3 or 4 years actually now. Um, and the Graph Builder actually is a library or set of methods and properties that allows you to create trees in LabVIEW. And so you can create trees and render them into different format. One of the format is, for example, GraphML or Plant UML and some others formats that you can create to actually visualize a tree. But you can also create some calculation based on trees. You can find a root node in a tree, try to go through all nodes in the tree. There are some algorithm based on tree structures actually, and Graph Builder tries to solve that. And actually, it's because of Olivier Jourdan that I started this library. So I must thank him. He was trying to create that graph in Antidoc, and we were talking together. He was saying, "Hey, that'd be cool if I can have something, a tool that helped me create a graph that represent all the interactions between modules in DQMH." And then, yeah, I said, okay, I can work on it and see how it goes. And I ended up actually with Graph Builder. Um, and for people who know me, actually, I learned, I'm not a programmer. At the beginning, I learned automation at school.
Hmm.
So I did a little bit of programming, but not that much. But for the programming I did at school was most of the code was C and C++. And when you learn C++, you learn linked lists. I
Hmm.
guess that's the word in English. And it was a nightmare to me. So it really is all the exercises, and I think I can still dream about that now, and it's as a nightmare. And Graph Builder is actually creating linked lists, but in LabVIEW. And so I went through my worst nightmare, and I actually created a library to which uses just that and solve tree related problems.
Okay, so the library actually is more about creating trees and the producing the graph ML is just kind of like a side effect.
Yeah, it's divided into, yeah, you have a part where you create a tree. So that's the tree creation part of the library. You have a part of the library where you can apply algorithms,
Hmm.
and you have a part of the library that can render a tree.
Okay.
And the way it was made, it's all object oriented, and you can inject actually behaviors, or you can it's all based on injection. So if I have got a method, for example, that is named render, and you inject the renderer that you want to use. So if you want to render a graph in GraphML format, you've got a class for that that is a GraphML renderer. And if you want to use plant UML, you've got a plant UML renderer, and you just inject that. And so if you have a new format that you want to use to actually display your tree, you can just extend that and create your own class.
Will it also render to like a LabVIEW tree control? Or is that would I have to write my own?
I didn't work on it, but it could. Yeah, it
Like,
could.
okay, cool. Yeah,
But
'cause I found graph or tree controls in LabVIEW to be kind of difficult.
it's very difficult to use, and it's a special kind of tree. It's tree control are in LabVIEW are really close to binary trees,
Hmm.
but trees that are handled by Graph Builder are general trees. So trees with path going back, for example, to a
So it's not
node and
directed.
things like
Yeah,
that.
like the get directed acyclic graph stuff.
Yes, exactly. So and so trying to describe such graph in a tree control in LabVIEW, it's a
Okay,
challenge.
so it's a
Actually, it's
different
not
type of.
possible.
Okay,
But
yeah.
yeah. But
And
for example, in LabVIEW, you could leverage something that I want to work on actually later. But I would love to be able to draw a graph in an image container
Mhm.
in LabVIEW, so you can just remove any dependency to any graph drawer engine like PlantUML, for
Oh,
example.
okay. Because I'm imagining now you could probably just export it as plant UML and run something locally to convert it and then display it.
Yeah, that's what happened in Antidoc actually.
Yeah.
So the renderer in Antidoc is actually creating a string describing the tree, and you've got a server that just getting the string and drawing the graph, and
Yeah.
that drawing is integrated into the PDF or HTML document that Antidoc produces. But I'd love to remove actually that dependency to any drawing engine.
Mhm.
And so, yeah, drawing directly the nodes and the vertices could be great. Another way that I'm exploring is to build actually SVG
Mhm.
images. So it's all vectors, and so it's pretty easy to create basic nodes and arrows, etc., and link them together. But it's not that easy.
Well, I
The,
mean, yeah.
the format is okay, but placing the nodes correctly and draw correctly the arrows, etc., without too much crossing, etc. So there are a bunch of algorithm behind the scene just to draw a graph.
Yeah, how
So
you lay the nodes out to minimize yeah, that's
exactly. So maybe one day the graph builder is open source actually. So if someone wants to participate to the project, uh, it's more than welcome. So yeah.
yeah, I guess open source, we should talk about that a little bit because that was one of the big announcements at NI Connect, right?
Yeah,
And now the
exactly. Yeah.
editor is open source.
Yes, that's the beginning. I was kind of circumspect actually about open sourcing part of LabVIEW. Uh, it's something that the champions or discussed actually with NI a little bit. So how we could leverage open source in LabVIEW, and I guess open sourcing the IDE, sorry, is kind of great. I love the idea. I just don't want NI to actually drop the maintenance of some parts of LabVIEW because it's open source. Hey, you can do it yourself. Oh, yes, I know, but yeah,
Yeah.
maybe I'm not interested into it.
Well,
So
also,
yeah, doing a
yeah,
few things like the icon editor, I guess, yeah, it's great. Good move. Uh, I hope they will not open source everything and use it as an excuse, but yeah.
well, there's also the problem if they open source everything, including all the like C and C++ code behind the scenes, none of us can really maintain that.
No, I think it's a big monolith or a big two big systems that we could actually actually everyone could break it, but extend it correctly. Yeah, I don't think it's really valuable to open that.
Yeah, but there are certain things like allowing, like for example, some of the industrial communications and stuff, like NI does like the 90% solution and gets it working, and then they lose interest. And if you need that extra 20% that they haven't implemented yet, it would be really nice if it was open source and you could go add that.
Yes, no, I would love to see NI actually when they are deprecating support to any toolkit to actually make it open source. And so anyone interested into maintaining it and making it evolving could do it. That would be great. Yeah, but we are more here talking about toolkits.
Yeah.
So code on the side that is loaded inside the LabVIEW IDE. Um, so yeah, I'm in favor definitely for this. Open sourcing the IDE itself, I don't know. Maybe for things like project providers or
Yeah.
an APM or things like this that are not working so well, maybe, yeah, that could help a lot. But still, I will wait a little bit and see how it goes.
Yeah, I think that's kind of the boat everybody's in. Yeah, my one worry about the icon editor is I think in some ways it's a good choice because it's a good low hanging fruit. It's already the source is already out there. It's easy enough. It's written in LabVIEW. My worry about it is I don't think there's a lot of people who really want to contribute to it. But I saw Jim put up some issues, so that's what I was waiting for was seeing an issue that I could actually work on. Because I don't I don't have a problem with the icon editor as is. Like it seems to work. I'm sure there's stuff that could be better, but like
Yeah,
it
there are a
it's
few things
low
that
on my
can be
priority
done
list
better.
things to fix.
What I'm more afraid of here with the icon editor is that many people will fork it and we will have a 1 million flavor of icon editor out there. And at the end, you don't know which one to pick. And so, yeah,
Yeah.
unless someone really update one major repository and everyone participate into that repository, yeah, at the end, it's often like that in open source. You've got one big solution that is working well, and you've got 1 million forks because people want to add that little something,
Yeah.
and you have to use that specific fork or another, etc. It begins kind of a hell to maintain actually dependency on an open source project. The other fear I've got is that, and we've seen that in the industry actually, that people are using an open source project and all of a sudden that open source project disappears
Ah,
or
that
it
too, yeah.
and then you are stuck with something you don't really understand and people modified it, etc. And you're stuck with that. You are just using a bunch of code that you don't even understand or that is not available anymore. So yeah, let's hope that NI is open sourcing things that the community will maintain correctly, but NI won't drop it. Okay.
Well, another consideration too, though, like you went one direction, but I was thinking a different direction that if you look at recent events, there's that XZ backdoor. Like if you
Yeah,
open source the icon editor and somebody pushes something to it, there,
yeah.
VIs are binary blobs. I wouldn't be surprised if there's a way to have a VI that compiles and runs through VI analyzer and everything's good, and you can embed some code in there. There has to be a way to do that.
I mean, it's pretty easy in LabVIEW. You know how big can be a diagram?
Yeah, giant.
Just add a VI that just mess up with your system and you push it far away in your diagram. And if you don't open the navigation window, you will never find out it's there.
There's actually so there are lots of security risks just like downloading code from like the NI forums. People download code all the time from there and run it.
Yep.
And it's very easy to slide something underneath something or make a something with a transparent icon. Do that too.
Yeah. Yeah.
There's various different ways to hide stuff and yeah, I think as LabVIEW programmers, we don't think enough about security in general.
In general, yes, because we have the habit that NI does all the job. And so we we wait for NI to actually bring some of the to actually address the pain of the solution. So that's what LabVIEW does, or that's what NI do actually with most of their software and toolkit and solutions. They address the main pains that developers have. For example, look at TestStand. TestStand is solving the problem of developers creating sequences.
Hmm.
So it's a solution among others, but you just can plug into TestStand and I just did all the engine, etc., and you just customize what you need. And so with an eye, it's often an habit for people just to look at what an eye has, and if it doesn't have it, or if an eye is not proposing something, they just drop it or assume it's not there, and they don't invest much more into it. And that's the case with security, actually. And so we expect actually LabVIEW to be secure. I don't know exactly what that means, but is it secure? Do we even talk about security in the LabVIEW world? We do, but not a lot, actually.
Yeah.
Because we expect an AI to take care of that pain for us. But we discover lately, actually, that it's not the case at all. So, yeah, LabVIEW developers should be more aware of security and what that means actually with LabVIEW and the tools and systems they create with LabVIEW.
Yeah, I think like when I started back in the day, the old adage was always like, oh, well, this thing is behind our corporate firewall, so therefore we don't have to worry. And being behind a corporate firewall does keep you from some threats, right? Like the hacker sitting in North Korea is probably not going to be able to get to your thing. But like once that person gets inside the network somehow, through some other means, it's game over if you don't have any like defense in depth and you're
Yeah.
not worried about it. So I think that posture is going away. I don't think that's good enough anymore.
And it's always a game of having security closer to the end device. If you protect your network, actually, everything that is inside the network might be protected uh, until it's not anymore. And if you don't have security closer to your end device and someone penetrate your network, you are into problem, actually. And if you take a look at what LabVIEW brings in terms of security, how do we make sure, for example, that an executable was not modified or a VI was not modified?
Hmm.
There are a few things out there. You can, when you build an exe, you can attach a certificate, for example.
Yep.
But then you have to find out how to create your own certificate.
Hmm.
And that's a pain.
Yeah.
And does NI have a solution for this? Actually, no. And people are used to NI addressing the pain of a solution. So for every exe I see or every build spec I see out there, maybe I remember one or two having a certificate actually activated,
Yeah.
but most of the time it's not,
Well,
and
there's
nothing
also yeah.
enforces that.
There's also the idea of like plugin architectures and signing like PPLs and stuff too. Because if you're
Yeah,
loading PPLs and you're loading random PPLs into your project, or even if you know what you're loading, but it's you're calling out the path, somebody could replace that with something
yeah,
malicious, and it would be very easy. And I
and
remember having a conversation with Derek Trepanier about this. He's like, "Oh yeah, you just sign it and it's easy." And I'm like, "Okay, that's great. That's easy for you, Derek." I'm
for
like,
you,
I
yeah,
understand the process. Like I intellectually I know what has to have to happen, but I don't know how to do it. Like off the top.
exactly.
Yeah.
And most of us out there are using LabVIEW. We don't know, and we don't want to know actually why. Because we've been trained like this. We have the habit that NI is handling the pain for us, and actually it's not true. We discovered that on Linux RT system lately, and we had customers asking for security. How do you know that my PXI system is actually secure? Or how do you enforce security in a compact Rio, for example? And so we lately found out that there is almost nothing in terms of security on these targets.
Oh, they have default usernames and passwords and stuff. They still Silverlight exposed. Like there's all kinds of crazy stuff.
Yeah, we see a lot of Silverlight out there
Yeah.
still like even if Silverlight was deprecated in what
Ten-
almost 10 years ago.
Yeah.
Yeah, and we still see Silverlight a lot at customer side. So yeah, it's still a problem. But for example, did you know that on every NI Linux target there is a firewall there?
Is it just the basic like Linux IP tables, UFW
It's
type stuff?
actually it's there. IP table is there. Yeah, it's basic. It works. It's a firewall,
Yeah.
but the firewall is there. It's active and it lets everything pass.
Uh,
It's set to allow everything.
yeah,
So
no, yeah, that's definitely yeah. Well,
first, you have to know that it's there.
mhm.
And second, you have to find out that it allows everything to go through your compact Rio in and out.
Yeah,
That's a little
the
bit weird. We are speaking here
trade-off.
about a firewall. It's basic.
Yeah.
It's pretty basic, and we expect NI actually to take care of this, but it's not.
Well, also, I feel like anytime you're making those decisions, right, it's a security versus convenience trade-off. And NI in this case chose convenience because, hey, if we've got it on the network, we can talk to it. We don't want people having to fiddle with firewalls in order to get to talk to their device for the same reason that they all have the same default username and password, right? It's like
Yeah,
stupid easy to go do that because
but,
anybody can
but
get into it. But then the problem is anybody can get into it.
exactly. Once you know how to access to these kind of targets, it's pretty easy to get there and to enter. At most of my customer sites, I can connect to any target with a basic default user password
Yeah.
that is shipped with every target. So there is nothing to enforce that.
Well, I remember working at a customer site and they had their own little local network for something. and I wanted to change some setting, and I forget what it was on the router, and I couldn't get in, and I just looked at it, and I looked at the model number, and I just Googled it, and I said, "What's the default username and password?" And like
Yeah.
that quick, I was in, and I was like, "That should not be
Yeah.
that easy." Like, yeah,
Yeah, definitely.
nobody wanted to ask, so I was just like, "Oh, I'll look it up." And yeah, and I feel like so yeah, it's not just the NI devices, but it's also like the security of the whole thing too.
But
So
if things are going to change actually in the months to come, at least in the US and I guess also in European Union, now there are some uh, uh, security measures that people working in certain fields, for example, aerospace and aeronautics, must comply to. So, for example, in the US, it's NIST. So
mhm.
the NIST protocol needs to be actually run on every system that is actually active on a aeronautic or aerospace system. So, and these documents enforce security on the end device.
Mhm.
So people will need to confirm to comply to NIST list. It's 110 security points that everyone should ensure that all points are covered actually. And there is a lot of work when you have NI targets to be compliant with that NIST document. And that's why actually we worked on some products for NI Linux RT to actually help people to securize your end targets, help securizing compact reuse and PXI targets. So we revived, for example, the firewall. We made it easy to set because IP table, it's all command line. You can lock yourself out of the device. Actually, you can just block your own SSH connection
Yeah.
with the device, and the only way to get it back is to format it. Actually,
Mhm.
and so we made the firewall like a little bit more accessible to LabVIEW or NI user. As the solution we have is that it's a dialog actually inside your SSH console, and you just check the Linux the NI tool that you installed on your target, and it opens the ports for you, and it blocks everything else.
Okay,
Uh,
so it knows the NI services and what ports they're on, and it just
Yeah, you're using system link. Okay, behind the scene, we know which ports are used and we open an exception in the firewall.
yep,
By default, everything is closed,
yep.
but we open exception just for this. And people just check the service they have and they can enter also TCP or UDP port they use in their specific application just to let them go through the firewall. It's pretty basic, but now the firewall is usable thanks to that solution. And we also are working on WireGuard. So we have a WireGuard solution that you can install on Compact Rios and PXI target. So thanks to WireGuard, you can actually leverage that. It's a VPN. Actually, WireGuard is a VPN, but it encrypts for free everything that goes out your real-time target. And you can also decide which target are authorized to actually talk to you. So you can, thanks to the VPN settings, you can actually block also undesired connection on a specific target. So we made a bunch of script to help people installing WireGuard on Linux or target and be able to set it up quite easily.
Yeah,
So we
those
are
networking things are not trivial.
no, it's not.
Yeah, I mean,
It's
if you know what you're doing, they're not too bad. But the problem is, most of us don't know what we're doing, so it's
no, and
screw it up.
actually, we found out that WireGuard was available since 2023 on the Rio image that you get
Oh,
from NI. But you can install it quite easily. But when you restart your target, it's gone. So
wow.
it's kind of a pain. So we had to actually reverse engineer how NI Linux RT target was working to actually make a script that overpass the behavior of the standard NI Linux RT system to actually mount the WireGuard virtual Ethernet board.
Okay, yeah.
So yeah, we had to reverse engineer that, because NI Linux RT is open source actually, so you can get the source and see how it works. But yeah, it was pain. Actually,
Yeah,
it's not an easy thing.
I remember that discussion because I was thinking it would be very easy. I'm like, oh, you just install it, and then it's like,
Yeah,
no, yeah,
you can.
it's not the normal Linux system. Yeah, it's got its own special conditions and flavors.
Yeah. And right now we are also working on trying to sign and encrypt RTXE
Ah,
also. So the idea would be to sign the RTXE on Windows when you build actually with LabVIEW your RTXE. And then when you send your RTXE onto NI Linux RT, you would have a process that is actually verifying on the target that the RTXE is legitimate and that no one changed it.
yeah, that's good.
So that's what we're working on right now. It's not easy. There are a few things like this that are not easy.
Yeah.
And yeah, we know that NI had solution out of the box, but no.
Well, I wonder though, does that just change the problem though? Because before the problem was, okay, anybody could put anything on the machine. Now the problem is I've got to manage this key for the signing. And are LabVIEW developers sophisticated enough to be able to do that? That
We need to help people actually
Yeah,
because of the habit of NI doing all the pain point of the solution. We need still to help people leveraging security systems and solutions. So we need to make it fast and easy.
yeah.
And yeah, with security, it's always it's not that easy to make things easy. So yeah.
Something else I kind of wanted to talk about a little bit was you mentioned virtual machines and RDP and some stuff like that you kind of have like some sort of setup for develop. Are you using VMs for development, CI/CD, both? How does
So yeah, we use VMs a lot actually. So the first solution we had is that every developer had had VMs actually on their PC, and we were running the VMs locally on our PCs. Uh, but sometimes we need to work on two projects at the same time, have one open and open another one on different LabVIEW system, and then you need to have a quite powerful PC to have two VMs running in parallel on your system, etc. So it began to be a pain point, and also since we are working on many projects and many flavor of LabVIEW and toolkits, etc., we tend to have a lot of VMs actually on our own computers. So the idea was to try to find a solution for this. And we ended up having a big server, actually, the VMware server in-house. And all VMs are actually running on that server. And all developers, when they are at the office or working from their home, they just connect to the server, and we use Windows or DP to actually use the VM, so remote desktop.
so the RDP then though is like tunneled through a VPN or something, I
Yeah,
imagine.
we've got a VPN. It's a WireGuard.
Yeah.
That's how
No,
you
because
use it.
RDP by itself is very insecure, as I'm sure you're aware.
Yeah. It's lightweight, so you need to have a layer of security on top
Yeah.
of that. And yeah, it's going through a VPN. And so, but we address every VM thanks to RDP, and so we can have actually on the server we have more than 50 VMs running actually now, and all the developers are using them quite easily. And now we have very lightweight PCs. Mine is a i7, but pretty basic one. And I don't need that much power. I don't need a big disk, and I don't need a big external drive just to store all my VMs like I had before,
Yep.
and everything is running there. And so we were able to leverage that capability to actually work with CI/CD internally. So we worked actually together. You gave me a training
Mhm.
for that and leverage actually GitLab. We run GitLab on a VM on that server. Uh, and so leveraging GitLab CI pipelines to do some CI. We are at the very beginning of CI, to be honest, at Neosoft Technologies. Um, we wanted to use CI to really enhance the quality of the code, but also as a way to gain time.
Mhm.
So we want the computer to do what the user, what the developer is actually doing manually. And for most of the project we work on, for example, compiling does not take that much time. So and we work a lot with unit test, and unit test is pretty fast actually to run for the systems we are working on. And so at the beginning, I wanted to use CI to actually build my executable and run my test and build installers, etc. But we found out it just takes time
Mhm.
to set that up, and it was not really helping us. So instead of that, we are currently working on CI just to enhance quality.
Okay.
So running VI server, and we are also VI server, sorry, VI analyzer to get some insight of the quality of the code. So the idea is not to create an executable or an installer, but to get an idea of what is the quality of the code I'm building now.
I have a question for you when it comes to VI Analyzer, because I always struggle with using VI Analyzer as part of CI/CD because I'm always like, what do I do with the results?
Yeah,
Right?
that's
So that
that's a
it has to
problem.
pass, in which case that's really hard and it doesn't work well
Yeah.
with like legacy code because if I inherit code, it's inevitably not going to pass. And am I going to fix every little thing? That's a problem.
It's a problem we are trying to address right now. The VI analyzer is a little bit too chatty, actually,
Yeah.
and so if you need to, quality is sometimes a question of balance. So we the idea we had was to create actually specific tests for things that actually matters and run them to the VI analyzer and have a like a Neosoft VI analyzer system.
Mhm.
So today we don't have that. We just have an email full of complaints, but and we have to analyze it ourselves. But it's the beginning of that. So yeah, VI Analyzer today is it works, but it doesn't give exactly what we were expecting. We are also working on TestStand to integrate TestStand with CI/CD, and it's much more CIs. There is an equivalent to VI Analyzer in TestStand
Mhm.
that is a little bit less chatty and is uh, much valuable actually in terms of output. And so we are working on integrating this sequence analyzer through CI. And with TestStand, we are also using testers deployment to create installers for the TestStand sequence and environments. And this can also be addressed thanks to CI. So we are working on it now.
That's cool. Yeah, that's almost like the exact opposite of my CI process. Mine is mostly concerned with building and testing. But I think you hit on a point that I think is worth noting. Like, we think of quality as like either it's good quality or low quality, but I kind of like I've seen some things that show like good, better, best. Like here, this is good enough. Here's a better way to do it. Here's the best way that we know how to do it. And I feel like if we think of things on like a continuum like that, it just seems, I mean, it's hard to right to put that into a CI/CD system and say, okay, great, does this pass or fail, right? Like
No.
that kind of wants like a hard black or white answer. Um, one of the things I thought about doing with BI Analyzer was to have it just keep track of like the number of failures, and if the number of failures goes up, then
Yeah,
it should
it's
flag
all.
it and like kind of like a ratchet. Because like you know you inherit existing code, maybe it has 2,000 failures, so you set the limit at like 2,000, and then you make some fixes, and if you introduce more failures, then it flags it or something.
Yeah, it delivers indicators actually. So
Yeah.
you have to trust that indicators and care about them. And yes, this is a question of who is reading
Yeah.
the result and how people interpret the result. So yeah, we have a saying in French, actually. I don't know if it's the same in English, but we say that best is enemy of good.
Yes. No, that
So yeah, so the question of quality is to have good quality. Trying to reach the best quality is always, yeah, it's honorable, but sometimes it's just a lack of time and people don't care about it. So
yeah.
we have to find the good, actually the good solution and spend the right amount of time to have the right level of quality.
Yeah. I have one more question about VA Analyzer though, before we move on, and that is, have you figured out a way, and I've always thought about trying to do this, but I haven't implemented it, to run it on just the change files, or do you run it on everything all the time?
We run it on everything all the time.
Yeah, because
So
that's my big complaint about VA analyzers, that it like takes forever. And if you run it on everything and you check it every time, now you're checking all these files that you've checked before and haven't changed. And yeah.
yeah, for the moment, it's very experimental on our side. It's just emails we've got. It was the idea was to leverage the system we have, the server and VMs that we can start quite easily, and we are not limited in terms of number of VMs and things like this. They are really we can throw them away quite easily. So the idea was to see what we could do with that. But yeah, VI Analyzer is a little bit too chatty, so maybe we will just drop the experiment soon and maybe focus a bit more on testing. I was speaking about earning some time before. Building a test and deployment can take 30 to 1 hour, 30 minutes to 1 hour to actually go through a big deployment and have something built. And so in that case, it's very interesting to get the installer made using CI.
Mhm. No,
And
that's
the sequence analyzer also. So sequence analyzer is very good in testing, actually. There are a few things that you can just uh, uh, avoid, actually, but it's a little bit less chatty than VI analyzer, and it has very good analysis too. And so having the sequence analyzer in CI is very valuable. So we are working on it, actually.
yeah, I know. I've been working from moving away from VI Analyzer and trying to do more auto formatting. So I've been working on this blue auto formatter.
That blue, yeah, I've
And
seen that.
I don't know, yeah,
So
it hasn't really taken off yet, but I'm gonna give a presentation on it at GDevCon, so hopefully that will help. And I think you're giving a presentation on your security stuff, right?
yeah. I'm giving a 25-minute presentation, actually. I will just try to speak about a project that we were working on, and we try to use NI products on the edge, so as an IoT system. And so we discovered a lot of things in that project, and I will talk about that at GDevCon.
Yeah, while we're telling stories, there is a question that I always like to ask people, and that is, can you tell me a story about an experiment that you tried that didn't turn out the way you thought it would?
Oh yeah, actually, it's not something. It's something I lived actually, and it was in my first work, first company I was working for while I was in France, and we were working on a system that was testing brakes of trucks on a production line. So we had a box with instrumentation and sensors that one could actually tied at the end of a truck, and you could plug the sensor on the braking system and see if there was pressure in there. So
Okay.
it was pretty important because when the truck goes out of the assembly line, it runs actually. So the operator needs to brake, otherwise he may have an accident. So this system was very important on the production line. And the customer I was working for was working on an assembly line in Turkey.
Mhm.
So once we were working on the project, and I was the one actually installing the system, and the company just sent me in Turkey, and it was far from Istanbul. Actually, it was in Bursa. Bursa is a town across the Bosphore, so I had to to rent a car and with the car go on a boat and cross that internal sea and go to Bursa. And I arrived there almost at the same time as the system, so going through customs, etc. And the box was waiting for me at the facility in Turkey. And when I came into the facility, the box was obviously opened by customs, or I don't know what happened, but it was not in good shape actually. And just unpacking everything, I found out that one of the sensor was unsoldered actually, so the
Oh,
wires was damaged, and so I could not install the system because it has to work well. It
yeah.
had to work well, and so I don't speak Turkish. I think maybe people would have guessed, but and I was there in the company, so far from my country, people speaking Turkish all around me. I was not a lot of people speaking English actually, and I was there with my wire unsoldered and my sensors that was not working anymore. And so I had to go through the facility and find someone, and I was trying to show the wires unsoldered and trying to have some people understand me, and it was not that easy actually. And I finally found a guy. I don't know why, but he seen that I was in trouble with that. Maybe I was, yeah, my face was maybe speaking for me, but and he made a sign to me, follow me, just or something like that, I guess. And he bring me at some place where they had an iron to solder
Yep.
the wires, but something I've never seen before. You could see the iron turning yellow and then white, because of the
Yep.
current going through
Totally.
and making it heat. Actually, it was like a big stuff. I don't know what they were ironing with that, but it was way too big for my wire. But I only had that actually, so we had to try, and one people came, and then a second one and a third one, and we were all trying to solder that wire, and at maybe 10 minutes after, we were maybe 20 guys around me, just trying to help me wire that iron that wire into the sensor. They were all speaking Turkish. I was not. So 20 plus one people trying to understand each other with tools that was not really made to make the job, actually.
Yeah.
And we finally made it. And the wires went back as the sensor, all soldered correctly, etc. And it was like universal. Everyone was clapping in their hands, and everyone was happy, and the system was working back, and I was able to actually deliver the solution. And actually, that day, and I will always remember that day. Actually, that I was in a country that was not mine. People around was not speaking my language, and it was hard to things all things down. And the system I had in hands was very vital for the assembly line. It was a security system. And when you think that everything is lost because you've got too much there are too much things that are not going well. And sometimes you just need one person to help you, and it finally opens everything and solve everything for you. For small stuff. In my case, it was just to find an iron, actually. So it was not a big deal. But I will always remember that when you think that everything's lost and you don't have any more solution, and in life or in your work actually, that you're trying to solve a problem or your software is not working, etc. So just try to find someone, speak to someone, try to find someone, even someone is not close to you, and sometimes that someone has a solution. And so it was a big lesson of life actually that day. And yeah, I guess I will always remember. We always remember. Yeah.
That's a really cool story.
Yep,
I like it. Yeah, it kind of goes to like, sometimes the problems aren't technical, they're really just people problems. And so sometimes just like a little inspiration can go a long way.
definitely.
Yeah. All right. Well, thank you very much, Cyril. It's been a pleasure talking to you.
Thank you, Sam. Thank you very much. And so we'll see each other soon, I guess, at GTFCon.
Yeah. And hopefully some of our viewers or listeners will also join us. Thank you.
Cool. Thank you.
That's it for today's episode of the LabVIEW experiment. Thanks for listening. If you have any comments or questions, head over to thelabviewexperiment.com and drop me a note. And don't forget to subscribe to the podcast and follow us on Twitter and Instagram at the LV Experiment.